Hi friends, welcome to my channel Speed Revision in 10 minutes. In this video we will cover the concept of triangles. So let us begin. Triangle. A triangle is a closed figure having exactly 3 sides, 3 vertices and 3 angles. In this figure, ABC is a triangle with 3 vertices, vertex A, vertex B and vertex C. The corresponding angles, angle A, angle B and angle C. The side opposite to angle A is known as small a, the side opposite to angle B is known as small b and the side opposite to angle C is known as small c. Terms related to triangle. First, side. A line which joins 2 vertices of the triangle is called as side. In this triangle ABC, AB, BC and AC are sides. Second, angle. An angle is circular measure between 2 adjacent sides. Angle A, angle B and angle C are the 3 angles in triangle ABC. So, angle A is the circular measure between sides AB and AC. Fourth, the sum of all 3 angles of triangle is equal to 180 degree. That is, angle A plus angle B plus angle C is equal to 180 degree. Perimeter. The perimeter of triangle is equal to sum of sides of triangle is equal to AB plus BC plus CA is equal to small a plus small b plus small c. Now area. Area of triangle is equal to half into base into perpendicular height. In this triangle ABC, AB is the perpendicular height. So the formula of area is equal to half into BC into AB. Now let us study about the congruency and similarity of figures. Two figures having same shape and same size are known as congruent figures, whereas two figures having same shape but not necessarily the same size are known as similar figures. So all congruent figures are similar, but all similar figures may not be congruent. For example, all circles, all triangles and all squares are similar, but they might not be congruent respectively as they might not have equal sizes. Now let us apply these concepts of congruency and similarity to triangles. Two triangles having same shape and corresponding angles are called as congruent triangles. For example, triangle ABC is congruent triangle DEF. In this figure, angle A is equal to angle D, angle B is equal to angle E and angle C is equal to angle F. Also, AB is equal to DE and BC is equal to EF and CA is equal to FA, which means corresponding angles and corresponding sides of both the triangles are equal. So, both triangles are congruent. Now, similar triangles. Two triangles having same shape or angles but not necessarily the same size are similar. That is, their corresponding angles are equal and their corresponding sides are in the same ratio. For example, in this figure, triangle JKL is similar to triangle PQR as their corresponding angles are equal. That is, angle J is equal to angle P, angle K is equal to angle Q and angle L is equal to angle R. Also, their corresponding sides are proportional. That is, JK by PQ is equal to KL by QR is equal to LJ by PR. Hence, both the triangles JKL and PQR are similar to each other. Now let us study some theorems of triangles. Theorem 1. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Consider triangle ABC. If we draw DE parallel to BC, then it divides sides AB and AC in same ratio. That is, AD by DB is equal to AE by EC. Now theorem 2 is converse of theorem 1 and it states that if a line divides the two adjacent sides of triangle in the same ratio, then the line is parallel to the third side. That is, it is given that AD by DB is equal to AE by EC. So it implies DE is parallel to BC. Theorem 3. If all the 3 corresponding angles of two triangles are equal, then the corresponding sides of the two triangles are in the same ratio. And this rule is known as the angle similarity rule of triangles. Consider triangle ABC and triangle DEF. It is given that angle A is equal to angle D, angle B is equal to angle E and angle C equal to angle F. So it implies that their corresponding sides are proportional. Theorem 4. If sides of one triangle are proportional to corresponding sides of other triangle, then their corresponding sides are equal and the two triangles are similar. This rule is known as the SSS similarity rule of triangles or side-side similarity rule. For example, it is given that AB by DE is equal to AC by DF is equal to BC by EF. So it implies angle A is equal to angle D, angle B is equal to angle E and angle C equal to angle F. Theorem 5. If one angle of a triangle is equal to an angle of other triangle and the sides including these angles are proportional, then the two triangles are similar. That is, it is given that AB by DE is equal to BC by EF. Also, the common angle, angle B and angle E are correspondingly equal. So, the triangles ABC and DEF are similar. And this rule is known as side angle side similarity rule of triangles. The point here to note is that the angle that we are going to consider must be the angle between the two proportional sides. That is, if side AB is proportional to DE and BC is proportional to EF, then we must consider angle B and angle E only. However, if we consider angle A or angle D, which is not included between these proportional sides, then this criteria will not be equal to side angle side. Theorem 6. The ratio of areas of two similar triangles is equal to the ratio of squares of their corresponding sides. For example, in similar triangles ABC and DEF, the ratio of areas of ABC and DEF is equal to square of ratio of their corresponding sides is equal to AB square upon DE square. Pythagoras theorem. In a right triangle, the square of hypotenuse is equal to the square of the other two sides of the triangle. Consider right triangle ABC, which is right angle at B, that is angle B equal to 90 degree. So Pythagoras theorem implies that hypotenuse square is equal to base square plus perpendicular square, that is AC square is equal to AB square plus BC square. The converse of Pythagoras theorem is also true. So converse implies that if square of one side of a triangle is equal to the sum of squares of other two sides of the triangle, then the triangle is a right angle triangle and the angle opposite to the first side or the angle opposite to the hypotenuse is a right angle. Theorem 8. If a perpendicular is drawn from the vertex of a right angle triangle to the hypotenuse, then the triangle on both sides of the perpendicular are similar to the whole triangle and to each other. Consider triangle ABC, right angle at B. Then if we draw a perpendicular from vertex B on the hypotenuse AC, then this perpendicular BD divides triangle ABC in two triangles which are similar to each other as well as to the bigger triangle ABC. So it implies that triangle ABC is similar to triangle ADB, which is also similar to triangle BDC. Now let us take some revision questions. Find the perimeter and area of triangle ABC having sides AB, BC and CA 10 cm, 12 cm and 14 cm respectively, and the perpendicular of length 10 cm. So the perimeter is equal to sum of sides is equal to 36 cm. Area is equal to half into base into perpendicular height is equal to half into BC into AD, which is equal to 60 cm square. Let's move to second question. Find angle A if angle B is equal to 89 degree and angle C is equal to 31 degree in triangle ABC. We are given two angles of triangle ABC. So the third angle can be found out easily by using the formula. Sum of angles of triangle ABC is equal to 180 degree, that is angle A plus angle B plus angle C equal to 180 degree, which implies angle A is equal to 180 degree minus angle B minus angle C, which is equal to 180 minus 89 minus 31 equal to 60 degree. Let's move to third question. Find the length of base BC of a right angle triangle ABC, right angle at B, if AB equal to 12 cm and AC equal to 13 cm. In this right triangle ABC, right angle at B, hypotenuse square is equal to base square plus perpendicular square, which implies AC square is equal to AB square plus BC square using Pythagoras theorem. So it implies that 13 square is equal to 12 square plus BC square, which implies the value of BC comes out to be 5 cm. This concludes this chapter on triangle. Please share and subscribe to my channel if you like this video. Now let us move to the next chapter, which is coordinate geometry.